Complete the table for absolute and relative change, and then we're going to use this table to answer a few questions. So first things first, absolute change. Well, in this first one, hopefully you remember that absolute change is the new value minus the old value, and then relative change is new minus old divided by the old. So for time of 0, we can't find an absolute and relative change because we don't have an old value. The 0 would be considered the new value. So these two here are non-existent. There is no old, so you're good. So in order to find the absolute change, for this one here, I'm gonna mark it here in pink. To find this value, here's my new value, here's my old value. So 45.84 minus 39.18, and I get an absolute change of 6.66. Then I take that answer, that's 6.66, and I divide by the relative, or excuse me, to find the relative, I divide by the old value, which is 39.18. And that gives me a relative change of 0.17. Now, we definitely talked about relative change being percentages, so you could talk about this as 17%, right? Those are the same. All right, I would like you to hit pause and finish 2 through 5, and when you come back, I'll have the answers written in and you can double check them. All right, for each additional piece, so when you did the light blue, now this is new and this one is old. And when you subtract, you get 7.79, which is, and then when you divide by the old of 45.84, you get your 17%. Then when you move on to the next one, here's your new, here's your old, and again, you subtract and then divide. Then you go on again, here's your new, here's your old. You're going 1 year at a time until you finally write in new, old. Okay, so when you see this and you notice that it's the relative change, these are the values that are always the same. So recall that when you're answering the question linear or exponential, absolute, whoops, not an N, that's not what I wanted. Absolute talks about being linear, relative talks about exponential. But in order for one of those to exist, the values have to be consistent. So to be linear, all of these values would have to be the same. They're not, and therefore this is not linear. Not linear. For relative, all of these values should be the same, and they are. So this is exponential. It's not constant change. Constant change talks about being linear, which is absolute. Constant growth rate is exponential, which is relative. So we have a constant growth rate, and that is 17% or 0.17. So when we go to create a model, okay, well, our model has to start with, we're dealing kind of with the amount at the end is your initial amount times 1 plus the rate to the time. Well, we know what the rate is. The rate is 17%, but how much is our initial time? Well, when you go back to your spot, the initial time has the time of 0, because that's when you started. Time of 0 means nothing has passed. No time has passed. It's where I started. So 39.18 is my a sub 0. So a equals 39.18 times 1 plus 0.17 to the t. And of course, you can take your 1 plus 0.17 and end up with your final amount is 39.18 times 1.17 to the t. And there is my model. So now when I go to part D, it says use the model. A equals 39.18 times 1.17 to the t to predict when the time is 12. Time is 12. That means t equals 12. So A equals 39.18 times 1.17 raised to the 12th power. Now, depending on your calculator, you might be able to plug that in all at the same time. If you can't, you want to make sure that you do your exponent first, and after you have that final answer, then you multiply by 39.18. But at any rate, when the time is 12, our value is 257.81, and that's an approximate.